Okay, so this is the second and final small piece for the last slide in 2.4. It involves the intermediate value theorem, and it's necessary because we finally addressed the word continuous, and we know what this means. Okay, now here's what it says. Okay, based off this definition, and then we'll do an example of it. All right, so there is my xy curve. Oh, yeah, there we go. And we'll draw just some function here. Okay, and here's what I'm gonna do. I'm gonna call this A, and I'm gonna call this B. That would mean that this is f of A, basically A f of A as a coordinate. And down here, this would be B f of B. Okay, so here's what I'm gonna do. Let's say that f of x, and that's what I'll call this, is a closed interval from A to B. So I only care about from here to here, okay? Now let's assume that f of A does not equal f of B, and that makes sense. F of A is some positive number up here, and f of B is some negative number, and you can see they're nothing close, okay? It's not to say that one has to be a positive, one has to be a negative. It just says that they cannot be at the same vertical spot, which means they cannot lie horizontally next to each other. That makes sense, okay? Okay, so assuming that these are not at the same height, okay, that means there must be a k between f of A and f of B such that there's at least one number c between A and B such that f of C equals k. Now, think about what this is. K is somewhere between f of A and f of B. So I know f of A goes this high. F of B goes this low. That's what the second coordinate does. It tells you how high you go. Somewhere in between here, there must be a k. Okay, such that there is a respective c between A and B. So somewhere in between here, there must be a c, okay, which is basically an x value, okay, such that f of c is equal to k. All right, now, that's assuming that this is continuous, okay? So assuming this is A f of A and B f of B, if I'm curious about some value k that's in between these two respective y values, there must be one that exists, provided it's continuous, between A and B that we call some value c, okay? So let me draw another picture, and I'll show you what this is in context to the problem I'm giving you. Okay, so this is a cubic. It's an inverse Travolta. And if you graph it on your graphing calculator, it looks something like that. Okay. Now they're telling us a very specific A and B. It's between 0 and 1. So I don't want this entire picture necessarily, even though I kind of need it to draw it. I only want part of it. So I only want it from 0 to 1. Here's 0. Here's 1. Okay. Now, because I'm only looking at that picture, here's what they're asking in this specific case. They're saying there has to be a 0 between 0 and 1, okay, based off the information they share, okay? And what I know is that at 0, which is my lowest boundary, I get 0 cubed minus 4 times 0 plus 1, which is, if you do all that math, it's 1. Okay? And at this boundary down here, okay, I have f of 1. Okay, and that is negative 2. The K that they're using in this particular problem, okay, is determined by what they showed right here. They said there must be a 0, okay? Now, when you have a 0, that is the same thing as a root. And what that means is that your y value, somewhere between this 0 and 1, okay, has to be 0. Okay, so we have to have a y value of 0 somewhere between 0 and 1. Okay, and instead of calling it x in this definition, they actually use the letter C. Okay, there must be a letter C somewhere between A and B, okay, such that f of C is equal to K. So just know that that is the case. All right, now in theory, when I answer this question using the intermediate value theorem, I don't really have to write this part, okay? What I'm gonna say is that, you know what, at one endpoint, I got an x value of 0. When I plug it in, I get a 1. That is a positive number. And sometimes I'll use the second number, which is 1. I'll work that out, and I get a negative value. Okay. And if one of my endpoints gives me a positive result, and one of my endpoints gives me a y value that is a negative result, what that says is, as long as this is continuous, which it is, then I must have at least one root or one y value of 0, because 0 is in between these two y values of -2 and 1. Okay, so what I would say as a result, okay, because f of x is continuous, and that's an important word, okay, between 0 and 1, okay, then there must be at least one 0. Okay, and you can see there was one. We saw that just from the graph. But it's the idea that in this case, because one boundary gave me a 0 and the other boundary gave me an output of -2, somewhere in between 1 and -2, there has to be a 0. And it exists at some point C that I don't know what it is. Okay. Now keep in mind that they may not use a 0. Okay. Sometimes they'll make these in a case where when you plug in f of A, you get like 200. And when you do f of B, you get like 500. Okay, and instead of asking an original question where you have a 0, they'll say, hey, verify that somewhere in your function that you have f of C is equal to, say, 400. Okay, and what you would say is, hey, you know what, at some point C, which is in between my A and my B, there has to be a y value or an output of 400 because my one endpoint gave me 200 and my other endpoint gave me 500. And by the intermediate value theorem, okay, then there must be some value of C where I get a 400. Okay, and as long as you show that this exists for each of the endpoints, then this is also verified. Okay. Include in here IVT. I didn't really write that there, and that is really important, even if you're defining the definition in your answer. I once went to an AP conference and I said, what if you actually write the definition? Okay, but you don't write IVT, you actually explain it well, but you don't write it. They said they would still take a piece off. Okay, they want you to know this language here. Okay, so keep that in mind. All right, if you have any questions on this, holler at me. There's your assignments, okay? Again, this isn't due for a couple days, so take your time on it, and if you have some questions on it, holler and let me know. Okay, hope you have a great day.